Hello, this is Mr. Huber. In this lesson, we're going to look at permutations and combinations. These are ways to figure out the possible sets of outcomes for something. Before we get into permutations and combinations more specifically, talk about another way that we can figure out the number of combinations or possible outcomes of something happening. It's using something called the fundamental counting principle. A fundamental counting principle. It says that if we have two events, m and n, and they can happen in some number of ways, m ways and n ways, we're saying, right? If m can happen in 5 ways, this would be a 5. If event n, some other event can happen in 8 ways, this would be an 8. So these are the number of ways the events can happen. Then we can find the probability that event m followed by event n happening by multiplying the number of possibilities of each of those two different events. So we can find the number of possible outcomes by multiplying the number of possibilities of each event. So for instance, in this first example, a restaurant offers 5 different meats on their sandwiches with 3 different types of bread and 7 condiments. How many possible sandwiches can be ordered with 1 of each of those? So those are 3 different events. In the first thing I said, event M, event N, there was 2 events. Here there's 3 events. The 3 events are the meat, the bread, and the condiments. So we can multiply the possibilities of each of those. So there are 5 different meats times 3 different types of bread to choose times 7 different condiments. Again, we're assuming here you can only get 1 condiment on it. You multiply those together and you get 105. So it'd be 105 different possible ways to order a sandwich with those options. Right? We multiply the possibilities of each of those events. Right? See problem number 2 here. A security code is 2 letters followed by 3 numbers. Okay? How many possible security codes are there? So 2 letters. So the possible letters, there are 26 possible letters for the first letter and 26 possible letters for the second letter. Nothing's saying it can't be an A and an A. They could be the same letter twice. So 26 letters, and then 3 numbers. So 3 digits. There are 10 possible digits, including 0 through 9, and there are 3 of those. So the possible security codes would be the number of letters times the number of possible letters, right? Possible outcomes. The digits can be any of 10 digits in those 3 places. So 2 letters, 3 numbers. We multiply all those together, and we would find that the possible combinations there would be 676,000. There are 676,000 different possible security codes. So fundamental counting principle, multiply the possibilities of each of the events and you get the total possibilities of each of the events happening one after the next. Now let's talk about permutations and combinations. The biggest thing that you need to know here is that when you're dealing with a permutation, the order of the events matters. When you're dealing with a combination, the order does not matter. Okay, we're going to see how those come into play. Pay attention to, does the order matter or does the order not matter? And then we're going to talk about how we actually calculate the permutations and combinations. First, we have to know which one we're calculating because it's a different calculation for each option. Okay, so here we're just going to determine, is it a permutation or combination? Does order matter or does it not matter? So number 3 here says 3 students are being selected from 550 at Brother Rice to meet with the Archbishop. So does the order matter? It does not matter which order you get selected. It doesn't matter if you're the first of the 3 students or the third of the 3 students. If you're one of the 3 students, it's the same, whether you're picked first, second, or third. Okay, so order does not matter. All that matters is we have 3 students. Which order we pick them in doesn't matter. So this is a combination. Okay, this is a combination. Order does not matter. Okay? Next, we see 3 students from Brother Rice are being selected for a grand prize, second prize, and third place prize. So the 3 different prizes, the place matters. Where you pick for the grand prize is different than if you're picked for the second prize or the third place prize. So different from number 3, where the order you're picked in doesn't matter. If you're one of the 3, you're meeting with the Archbishop either way. Now in number 4, order matters because it makes a difference if you're selected first for the grand prize, second, or then third. This is a permutation. Okay, a permutation. Okay, does order matter? Permutation, order matters. If it doesn't matter, we use a combination. All right, so keep in mind those terminology we're going to see And in the third example here, number 5, 11 players are selected from a roster of 17 to be starters in a soccer game. Again, it doesn't matter if you're the first player picked or the 11th player picked, you're going to be a starter. So order does not matter. This is a combination. I'll just put a C for combination, okay? Order does not matter. If you're one of the 11 players picked, you're starting the soccer game. Doesn't matter if you're the first one picked or the 11th one picked, you're a starter. So order does not matter. So you're starting to see an idea here of where we can figure out, does order matter or not? All right, that's the biggest thing to look for when we're calculating a combination or permutation. Now let's talk about maybe how we can actually solve these. After we look at number 6, the athlete's given name is Cassius Marcellus Clay. Who would that athlete be? Do you know who Cassius Marcellus Clay is? There's a couple photos. If you know who that might be, that is Muhammad Ali. He's considered one of the greatest athletes of all time. In fact, Sports Illustrated named him the greatest athlete of the 20th century. He was nicknamed the greatest, actually. And Muhammad Ali changed his name from Cassius Marcellus Clay. He converted to Islam. Okay? He was a conscientious objector to the Vietnam War, and he was stripped of his boxing titles as part of his way of speaking out for racial equality and just his opposition to the war itself. He won a gold medal in 1960 at 18 years old for the U.S., and in 1964, he won his first heavyweight title. This is a picture of that, where he knocked out Sonny Liston in 1964. That was his first time winning the heavyweight title. Then when he objected to the war and didn't go into the draft, he was stripped of his boxing titles and not allowed to box from 1967 to 1970, some of his prime years. But when he came back, he was still able to recapture the title. He fought in a couple of the biggest fights in boxing history. The Rumble in the Jungle, when he knocked out George Foreman, and the Thrilla in Manila, which was his third of 3 fights against Joe Frazier when he won by TKO. That bout was viewed by, at the time, a record 1 billion viewers worldwide. So Muhammad Ali was born Cassius Marcellus Clay. All right. If we want to calculate permutations and combinations, we're going to see something called factorial. It's where we use an exclamation point, okay? This right here is read as 4 factorial. When you see an exclamation point after a number, mathematically, it means factorial. It means you're multiplying this number times all of the integers lower than it all the way down to 1. So 4 factorial is 4 times 3 times 2 times 1, which comes out to 24. And that one wouldn't be too hard to calculate by hand and write out, but we do have a way to calculate these on your calculator. There's a factorial button option on there. So if you had like 19 factorial, you're not going to want to write out 19 times 18 times 17 times 16 times all the way down to 1 and calculate all that. So on your calculator, if you press the math button, which is on the left side, third one down on the left side says math, okay? Then when you're in the math menu, you'll see there's a couple different menus across the top. If you arrow to the right to the one that says PRB for probability, okay, menu, and when you do that, you'll see that, and you get some different options there below it. Option number 4 looks like an exclamation point, so it's factorial. So you can enter 4, then go find that button for factorial, enter it, and then press enter and make sure it should come out to 24. You know, make sure you know you're entering factorials correctly, which can be very helpful to have the calculator calculate those for you. And now let's see how we can use those with combinations and permutations. C for combination, P for permutations. And we're going to find out that there's a way to calculate these on the calculator as well, but this is how they are written out. So if you didn't have a calculator, you still could do it using factorials. Okay? The key thing to notice here is the N and the R. Those are your big pieces to this. N is the total number of possibilities in your data, okay? Right? The size of the full set. So when we talked about letters of the alphabet, this would be a 26. Okay, that's the total number of possible letters that you could have. R is how many of them you are selecting. Okay, that's the subset size, so the smaller set. Okay, it's the number of items you're selecting. So in the problem where we were talking about the students at Brother Rice, okay, if we're saying there's 550 students at Brother Rice and we're selecting 3 of them, we're selecting 3 out of the 550. So N is always the bigger number, that's the total amount in the grouping. R is the number you're selecting from that grouping, okay? And we can calculate combinations and permutations using factorials, or we can use the calculator. In that same menu you found when you press math and then arrowed over to PRB, option 2 and 3 are P, permutation, option 3, C for a combination. You'll see the N and the R there. So you have to enter the N and enter the R, and then the calculator will calculate for you these permutations and combinations. When you're entering them, one thing to keep in mind is you're going to have to enter the n first, the total number, then go in and pick the permutation or combination from that list under the PRB, probability listing. Pick the permutation and combination, and then you'll enter the R value. So you enter the n value, then go to this in the listing, then enter the R value. And you'll see how that works here and get a chance to practice it. So let's look at how many different ways this selection can be made. 3 students being selected from 550 at Brother Rice. So we talked about this in the previous examples. The first thing we have to look for is that order doesn't matter, so it's a combination. So we're going to do a combination of 550, that's our n. N is 550. That's a total number in our set of students, 550. We're selecting 3. That's our R value. So when you go in the calculator, you're going to type in 550. After you type in 550, you're going to go in the math menu over to PRB, and then you're going to do option 3, which is the C for combination. Press that, and you're going to see that symbol come up with the combination N and R. Then you're going to enter an R value. Enter 3 and press enter, and you should get an answer of 27,578,100. That's a lot of different ways that we can select 3 people from 550 at Brother Rice. Again, where order doesn't matter in this case. So check that out. Make sure you're able to enter these into your calculator correctly. If not, make sure you're seeing me to get some help, practicing it a few more times. Again, know how to enter this in your calculator so that you can get these calculations performed, because you're probably not going to want to do these with all the factorials that you have to do. And if you can't do this on the calculator, you probably can't do the factorial on the calculator, and that's a lot of calculation by hand. All right, so we want to make sure we have a method to do that. But the big thing is we have to know if it's a combination or permutation, so we enter it the right one in the calculator, because they're going to come out differently. We're going to see that here. In number 8, we saw this is a permutation. Okay, so this is a permutation because order matters. Are you getting the grand prize, second prize, or third place prize? There's a difference there. Okay, so now this is still 550 for our total, and we're selecting 3. Okay, so you're going to do the same thing. We're going to enter the n value, then go to the permutation option in that PRB menu, and then enter the 3 for the R, because you're selecting 3, but in this case, order matters, and so you're going to see you're going to get a different answer. You get 165,468,600. When order matters, it's going to be a bigger set of possibilities, because the same 3 people picked, which one's the first prize, second prize, and third place prize makes a difference, so there's more different possibilities. So know if it's a combination or permutation. You can see you're going to get a different answer even when the n and r values were the same. Okay. In this next one we saw was a combination, so we're going to do a combination of 17 players on the team, and we're selecting 11 of them. And that comes out to 12,376. 12,376 different possible sets of 11 starters. Again, where order doesn't matter in that case. I threw one more on here. Again, the biggest thing is going to be, do I know how to identify if there's a permutation or combination? Then can you enter it in the calculator? How many different lineups of 9 players can there be from a baseball team? So if you're familiar with baseball, the order matters in a lineup. Who's batting first is different than who's batting second, then who's batting third, fourth, fifth, all the way down through ninth. So in this case, since order matters, this is a permutation. There are 15 players, and we're selecting 9 of them. And order matters. You're going to find there is a large number of possible ways we can make a lineup of 9 players from 15. So if you have a team of 15 players, you can make 1,816,214,400 different baseball lineups of 9 players. Because again, order matters. The same 9 players can be arranged a lot of different ways depending on what order you put them in the batting order as well. So permutation, because order matters. So you can know how to identify combination and permutation. Does order matter or not? Make sure you know how to calculate these on the calculator, knowing what factorial is as well. And then back to our first thing, the counting principle, where if we have different possibilities, we can just multiply the different possible options and get our total.